Warning. This podcast does not introduce any new information outside the Foundation's curriculum. Listener discretion is advised.
Hey there, Foundations fam. Welcome back to another episode of Real Doctors, Real Friends, the official podcast of Foundations of Medicine. I'm your host, Shereen.
And I'm Roshan, your partner in medical education. We are so thrilled to be with you again this week.
Absolutely, Roshan, and we have some exciting news for our brand new class of 2029. You're officially the Central Liners. Congratulations, everyone.
Yes, congratulations. It is a fantastic name, and we hope it fosters a strong sense of community and collegiality among the class. We heard it was a busy week, and we've loved seeing all your engagement, both in the classroom and through your submitted questions.
It certainly was a lot of information this week, covering everything from the intricate world of proteins to the vast landscape of public health. We know that feeling of being overwhelmed, so today we want to unpack some of those key learning points and address some of the excellent questions you submitted.
That's right. Let's dive into some of the core concepts from this past week, drawing on the topics you asked about. So first up, a huge topic in our Foundation's curriculum, proteins and enzymes. Shereen, what were some of the big takeaways here?
Well, there's a lot to cover. We learned that proteins are crucial macromolecules classified into globular, so having a spherical shape, and fibrous, like long strands, and based on how their polypeptide chains are folded or arranged. Their function is intricately tied to their 3D structure, which is largely driven by the hydrophobic effect in soluble globular proteins. These structures are mainly stabilized by non-covalent interactions between amino acid side chains.
And sometimes these proteins need a little extra help, right? Like prosthetic groups. Those non-protein organic molecules permanently included in the structure are essential for function and offering additional chemical reactivity.
Exactly. But what happens when that structure goes wrong? We saw two powerful examples, sickle-cell anemia and prion diseases. In sickle cell, a single amino acid change in hemoglobin leads to abnormal hydrophobic interactions and the formation of hemoglobin fibers that distort red blood cells.
And prion diseases are even more striking, where a misfolded protein induces normally folded ones to misfold and aggregate into neurotoxic fibers, contributing to neurodegeneration. It really highlights how critical correct protein structure is for proper function.
Yeah. Moving on to enzymes, we learned that they're biological catalysts with superior reaction rates, milder conditions, greater specificity, and capacity for regulation compared to non-biological catalysts. They don't change the overall free energy of a reaction, but they drastically lower the activation energy barrier.
And they do this by binding substrates in their active state, ensuring proper proximity and orientation, participating in the reaction mechanism using amino acid side chains and cofactors, and critically, stabilizing the transition state better than the substrate itself. We also touched on how enzyme activity is regulated in various ways, from competitive inhibition and allostery to reversible covalent modification like phosphorylation and even inactive zymogen precursors.
Next up, the fascinating microscopic world of histology and the fundamental building blocks of life, cells, membranes, and transport.
Histology, as Dr. Raby taught us, is the study of microscopic anatomy. It helps us understand how cells organize into tissues and tissues into organs and organ systems. We also saw the four basic tissue types: epithelial, connective, muscle, and nervous tissue.
One of our listeners asked for clarification on histology, specifically about stains. So let's clarify that. Hematoxylin and eosin, or H and E, is the most common staining method. Hematoxylin is a basic dye with a positive charge that binds to negatively charged molecules like DNA and RNA. And this stains basophilic structures purple. So think of the nucleus.
Yeah, and eosin is an acidic dye with a negative charge, binding to basic components like cytoplasmic proteins and other elements, staining acidophilic structures red or pink. This contrast helps reveal cellular structures clearly.
Moving to cells and membranes, the fluid mosaic model describes the plasma membrane as a fluid structure with a mosaic of proteins and lipids embedded within it. This fluidity is vital for various cellular functions, and it's influenced by factors like phospholipid tail length, degree of saturation, temperature, and cholesterol content.
And the membrane isn't symmetrical, is it? We have different outward and inward facing aspects of proteins, carbohydrates only on outward surfaces, and different phospholipid compositions on each half of the bilayer, all supporting functional differences.
Right. We also covered movement across membranes, which is crucial for cell function. This includes simple diffusion for small nonpolar molecules, various types of vesicular transport like phagocytosis, which sometimes is described as cell eating, and pinocytosis, sometimes referred to as cell drinking, and the highly specific receptor-mediated endocytosis.
And for molecules that can't just diffuse, we rely on channels and transporter proteins. Channels allow very rapid, specific movement of ions, while transporters, though slower, can move substrates against concentration gradients using energy, as seen in primary and secondary active transport. Now, let's talk about embryology and its profound relevance. Dr. Hawking emphasized that embryology is the study of the processes that transform a fertilized egg into a newborn infant.
And why should medical students care beyond just finding it fascinating? This is a great question. So what? Who cares?
Right?
Well, it's crucial for managing pregnancies and understanding the importance of early development. It's also key to awareness and management of congenital malformations, which significantly affects about 3% of live newborns. Plus, embryology is a key to understanding both normal and unusual anatomy.
That's right. The formation of an embryo involves complex processes like cell proliferation, differentiation, migration, and even apoptosis. And Dr. Hawking highlighted that this understanding extends beyond birth, as development never truly ends, impacting genetics and opening doors for manipulating pregnancy and the clinical use of stem cells.
Right. Now let's get into the central organizing principle of physiology, which is homeostasis. I maybe know a thing or two
Just a
about
little.
that. So, Roshan, I think we got a lot of questions about this topic.
We definitely did. Homeostasis is all about the remarkable stability of your body state. Despite constant external and internal disturbances, it's a highly dynamic physiological process where life is held in equilibrium only through continual compensatory adjustment.
Now, one of our listeners asked about feed-forward mechanisms and dysregulation of homeostasis. Feed-forward control is fascinating because it allows our bodies to anticipate a change that's about to occur and initiate a response before the actual change happens. This helps to minimize disruption in key regulated variables in the body.
Think of the salivation reflex before you even taste food, or the complex cardiovascular and respiratory adjustments initiated by central command in anticipation of exercise. While it helps prevent initial disturbances that negative feedback loops can't, dysregulation could theoretically lead to problems if the anticipation is wrong or excessive, causing an overshoot or misaligned response. For example, in Juan's case that we had in our weekly review, his body's central command raised physiological set points for mean arterial pressure and rate of respiration in preparation for the race that he was doing.
Yeah, and in that particular case, that's actually a beneficial adaptation or a beneficial result of feed-forward regulation. But there was an example that I shared with one of our listeners at the end of class. For example, if you are anticipating having lunch, let's say, and you're thinking about your lunch, and some of those feed-forward mechanisms are not only going to initiate the salivary reflex, they're also going to initiate the release of certain hormones like insulin, for example. In some individuals, there is the possibility that if it's an even longer time than you anticipate, so let's say you get called away or something happens and you can't ingest nutrients in an appropriate period of time and you don't have proper compensation, that can potentially lead to hypoglycemia.
Right.
But for the majority of healthy people, you also have the counterbalancing effect of hormones like glucagon, which ultimately are going to help stabilize blood glucose levels until you are able to ingest a meal. But certainly, feed forward can lead to some complications. Now, another question touched on proportional control. We learned that proportional control is an example of tonic control, where a regulatory mechanism is always on and modulates a function to keep a variable within a set point. It's kind of like an example I shared in class, trying to keep our vehicle in our lane. We make constant tiny adjustments back and forth. Physiologically, the sympathetic control of blood vessel diameter is a good example. Our blood vessels are usually not completely dilated or constricted at rest, but it's somewhere in between. Increasing sympathetic activity induces vasoconstriction in most blood vessels, while reducing sympathetic activity tends to cause vasodilation.
Regarding the homeostatic response to exercise, a listener asked if we need to know the entire flowchart for assessment. Rather than memorizing the flow diagram, working through each step will help reinforce many concepts for homeostatic regulation, as well as upcoming content in week 3 related to cardiovascular physiology. The exercise flow diagram also reiterates mechanisms that were discussed for the regulation of blood pressure as well as thermoregulation, so it would be important to have a good understanding of these processes.
Yeah, when you see a big flow chart like that, sometimes it can be scary and it can feel like, whoa, this is a lot of information. But a lot of those points we had addressed leading up to that flow chart. And it's helpful to kind of break things down and go step by step and try to make sense of why one step leads to the next. Then you'll never be stuck in an exam scenario and you can really have a good comprehension of those concepts.
Absolutely.
For sure. Now, we also had a question about the internal environment and whether it includes only the extracellular fluid, ECF, or also the cell and intracellular fluid, ICF. So the intracellular fluid, yes, it's in our cells, which are in our bodies. But if we're talking about the internal environment from a homeostatic perspective, it's described as the sea within, and this primarily refers to the extracellular fluid that bathes all of our cells, that surrounds our cells. The extracellular fluid then continuously mixes with the intracellular fluid, so we get exchange back and forth, and the intracellular fluid itself makes up a distinct fluid compartment like we described.
And so the ECF acts as a bit of a buffer zone, and its stability is crucial because cells are intolerant to changes in their surroundings.
Absolutely. Absolutely. So we can think of the extracellular fluid as this optimal internal environment which protects the function of our cells. Now, for the, we got a question regarding the renal long-term component in response to increased mean arterial pressure. So we kind of touched on what happens when there's a reduction in blood pressure as a result of a reduction in blood volume and the way the kidney contributes to restoring blood volume and blood pressure. Does the kidney have a response in terms of an increased blood volume or an increased mean arterial pressure? And the answer is absolutely yes. We will discuss this in more detail during week 3, but kind of in a nutshell. An increase in mean arterial pressure or blood pressure can lead to increased stretch at arterial baroreceptors. So remember, we talked about those baroreceptors. That's going to relay information to cardiovascular control centers in the brain, and that's going to result in a reflex suppression in sympathetic nerve activity. That includes a decrease in renal sympathetic nerve activity, which then contributes to renal arteriolar vasodilation. Again, we're going to talk about this in week 3. This will increase filtration at the kidneys and help get rid of excess salt and water, thereby reducing blood volume back to normal and restoring mean arterial pressure. There are other factors as well, such as a decrease in vasopressin release, deactivation of the renin-angiotensin-aldosterone system, and increased atrial natriuretic peptide release. All of those things together will work to reduce renal salt and water reabsorption and ultimately lower mean arterial pressure as we get rid of that excess salt and water. This is part of the long-term regulation of blood volume, which involves the kidneys and is primarily hormonal, although renal nerves do play a role.
Finally, a listener asked about describing homeostasis using pH balance. The body maintains pH within a narrow range, and this is a classic example of homeostasis under tight control. Any deviation triggers compensatory mechanisms to restore the set point. Maintaining pH homeostasis is critical when we consider proteins and enzymes because altered pH will change the structure of these molecules, which ultimately compromises function. The means by which we maintain pH homeostasis can be quite complex and involves buffer systems in the circulation, the respiratory system and renal system. So for the purposes of an introduction, it is a lot to take in. We'll definitely learn more about pH regulation in pulmonary and renal blocks. And the reason I was giggling to myself a little bit is because I'm just reminding myself of a YouTube short from Dr. Mike talking where he commented on an influencer mentioning how it's important to either use, I think, to drink a lot of water with lemon in it. And in order to balance your pH, because there's this whole alkaline water thing that's this new thing. And he shows the pH, like the spectrum. He's like, we have a very narrow range. You are dead on either sides of those. There's not a lot of wiggle room here. So sorry, when I saw the narrow range, it was just brought to me that YouTube short.
We get a lot of acid in our foods anyway.
Oh my gosh! Like what the acidity of of our stomach is like a pH of like a 2.
But like even the foods we ingest tend to have more acid, and even the metabolic processes in our body tend to generate more acid. So actually what a big problem from a homeostatic perspective is we're constantly generating a lot of acid, and we have to buffer that. And we have multiple layers of systems that help regulate our pH within a narrow range. And again, like tying in this point with, let's say, the material that Dr. Wright shared with us, if you don't protect the structure of these proteins and enzymes, then they're not going to be able to function, and that can lead to serious complications or even death. So I would love to talk about everything in the 3 hours that I have for homeostasis, but some things we just have to leave for later on in your training. Now, one thing that I'll highlight, remember that one chemical signal can have different effects in different tissues. We saw an example with epinephrine, but there's many more. Epinephrine can have one effect in one tissue, a completely different effect in another tissue. Context is important. So some factors will have different effects in the body depending on concentration, for example, maybe the particular cell that's in question or the tissue, or even the overall state of the body. So definitely we have to keep in mind context.
Shifting gears a bit.
Shifting gears a lot.
A lot. But it permeates everything that we're talking about, which is public health, and specifically the social determinants of health. And this week, this is an area that directly impacts patient care, even if it feels far from the molecular level.
It truly does. We learned about the 12 determinants of health, which include income and social status, education and literacy, employment, working conditions, and social support networks, among others. These factors profoundly influence health outcomes and create health inequities.
Understanding these determinants is crucial for the specialists who work in public health and who focus on the health of entire populations. They use approaches like epidemiology, surveillance, and population health assessments to quote-unquote diagnose community health needs.
And then they treat, I guess, quote-unquote treat these issues with prevention programs. And these are categorized into primary, secondary, and tertiary prevention. For example, primary prevention aims to prevent disease before it even occurs. So something like immunizations, for example. Secondary prevention detects disease early to slow progression, like disease screening. And tertiary prevention reduces the impact of acute or clinical disease, like post-MI cardiac rehab.
And finally, let's talk about something incredibly relevant to you, the class of 2029, learning and study skills and performance mental skills, or PERMS. We know this journey is challenging, and we're here to support you and talk a little bit more about that.
A listener asked if confidently answering session objectives would be enough to cover the material and prepare for assessments. Our course guidelines state that all objectives in sessions throughout the course are fair game for assessment, with a mixture of application-based and knowledge retrieval questions. So yes, if you're able to confidently master those objectives, that's a great foundation and a great strategy for exam preparation. And I mean, exam for your or preparation for your role as a clinician in the future. It goes beyond exams now.
It does. And just to highlight, there are a few sessions in the block where, despite the fact that there are educational objectives, there aren't necessarily direct closed or open book assessments that are attached to it. So you can check that out in our Intro to Foundations lecture. The lecture slides we do include. There's a
And
few
we provide
sessions.
reminders too
Yes.
around
Yep.
those sessions.
And this is where really self-regulated learning comes in. It's a proactive process where you set goals, select learning strategies, and self-monitor your effectiveness. At this stage, it's really challenging to think about this, but there are some strategies to consider. And so the 6 strategies for effective learning, we've included it in the forum. We've also included a bit of a Google Doc that sort of stems from a specific example around actually homeostasis. And how to think about learning about a particular concept in homeostasis. So these 6 strategies for effective learning are fantastic tools for this. Retrieval practice, space practice, elaboration, dual coding, concrete examples, and interleaving. These are research-backed techniques to help you learn more effectively. We'll be exploring more in the Foundation Student Forum, so please stay tuned. We've already posted, and hopefully we can get some engagement on that. And building on that, we will introduce the concept of performance mental skills, or PERMS. And this is in an upcoming huddle session with the Office of Advocacy and Wellbeing, and something specific to foundations. We do this in partnership with the group, and basically we go over cognitive, behavioral, and emotional regulation skills that promote that healthy mental and physical states before, during, and after performance tasks. And as you just mentioned, Shereen, it's not just for high-stakes situations right now, like exams, but for everyday challenges, like when you see your first WOB or closed book exam.
Yeah. Or like a new challenge in the clinic, let's say, like in the future. The PERMS 3M plus S framework, I mean, you're killing me with all the acronyms. So this framework organizes these skills into mastery approaches, mindset and motivation, and self-regulation skills. These skills can be applied before the moment, so goal setting, reflective practice, imagery, in the moment, self-talk, emotional regulation, and after the moment for reflection and cognitive reframing. They help foster a growth mindset, which is essential, for life, but navigating the demands of medical education and developing your professional identity.
And we want to take a second here, maybe a little bit more than that, to just state very plainly that we're not going to pretend that any of this is easy. The road to medical school has been long for many of you, and seeing the content from this week can feel like it's only going to get rougher as the days go on. Recognize that the path to your end goal is filled with extremely small steps, not large leaps. Study strategies and understanding even these fundamental concepts take time. Recognize that you have the ability to ask questions and reflect on your progress, especially now early on in your training, and that those skills will carry you through the rest of your career. And having just come back from our sharing circle and having an opportunity to talk about sort of the much bigger picture in which our healthcare system lives in, which is basically our world, and the implications of decisions that have been made by people that have come before us. It's incredibly important for us to take the time to reflect. I actually, one of the reasons we're recording this podcast a little bit later is because I really did need to reflect after that session and actually engage in some small group discussion around the sort of the media that was shown to us today around the residential school system, because it is incredibly important to, after the moment, reflect, cognitively reframe, think about your place within the system, wrestle with it even, and wrestle with your, I guess, role in all of this, especially in medicine. So this isn't an easy road. Just imagine what your patients are also going through as well, right? They've had a rough road as well, especially in dealing with our healthcare system. So hopefully there's a way to be vulnerable, to open up to your patients, to recognize that vulnerability goes 2 ways, because that's really how we can actually move forward in a lot of the ways that we would like to, is just really opening up and finding out more about the person sitting across from you. That's a really important perspective, Roshan. And it's been a bit of a heavy week because it's our first week of curricular content. We also had the sharing circle, and that can be heavy to work through as well. So we'll end the podcast by a little bit of lighthearted moment.
So, speaking of challenges and what counts, it's time for the real test of our friendship. Now, this is a controversial one.
I know.
So, audiobooks.
Right.
Is this considered so-called real reading or not?
The problem is I don't know when the last time I read a real book was. So the audiobooks are my only way
Your go-to.
of consuming the written word.
Right.
I have listened to 5 audiobooks over the summer.
Oh, that's pretty good.
Oh,
That's pretty
it's not
good.
that much. It's all while exercising. It is incredible. The one that got me started was actually by Thomas King, the Inconvenient Indian.
Oh, okay.
That was incredible. If anyone's read Stephen Leacock, I think he's Canadian and American. I can't remember.
Yeah.
But it was narrated by Lorne Cardinal from Corner Gas.
Yeah.
Oh,
yeah.
it was incredible.
Oh, that's awesome.
It was incredible. It almost should be mandatory reading.
Oh, that's awesome.
But that's really what got me started on the audiobooks. And we watched, me and my partner, we watched Inside Chinatown, which is one of these new series on one of the streaming services. And then I read the audiobook. Spoiler alert or not spoiler alert, I actually like the movie more than the book.
Oh, no.
Because the book is more like a shorter story.
That rarely happens.
I know.
Usually the book is
sorry,
better,
it was a
right?
series. I just like the way they crafted the story.
Yeah.
The performances were good.
I like
but
how
the
you said that.
Story was
I read
really
the audiobook.
good. I listened.
You read the audiobook.
I listened with my ears.
So here's where I have some conflict. I love books. I like the sensory aspect of going to a library and walking through the stacks and physically picking up a book and flipping through the pages. And then there's the smell, and especially if it's like a brand new book versus like a used book, like there's so much that's a part of physically reading a book. But I also really appreciate that audiobooks have really improved accessibility for a lot of people. So I'm kind of torn. If I am forced to choose, I feel like a physical book is real reading. But I'm also not an auditory person.
This is exactly what I was going to say. If you have a phenomenal narrator, like if somebody who's got a great voice is narrating the audiobook, it makes a world of difference. I have been struggling with a audiobook that it's about burnout, but it's not what people think it is. It's actually written by like a critical philosopher and looks at it from a critical standpoint.
Yeah.
And so the person who is narrating this is so boring. And the content is pretty boring too, but I like it. Man, if they had somebody a little bit more engaging, I think I would be able. I've fallen asleep a few times, even though the content is actually incredibly relevant to what we've been talking about already.
Yeah.
I mean, I wish we took a critical lens to a lot of the issues that we have.
Yeah.
I think we still are mired in this sort of behaviorist, and we're moving towards this humanist approach, but it's sort of this weird humanist approach where it's not really humanist. I'm thinking about this from an educational pedagogy standpoint. So I do like to read and engage with content that does explore the critical perspective.
Yeah.
But oh my goodness, the narration makes such a big difference.
Do you know what this reminds me of?
What?
Okay.
Seinfeld episode? No.
Absolutely, it does. It does, Roshan. Okay, so we'll share with our listeners. We are huge fans of Seinfeld. There's a lot you can learn about life from this show, and a lot you can learn about medicine, which is probably going to figure into a lot of our podcast episodes.
I mean the accessible parking stalls.
And I mean the when they act as a patient, standardized patient.
Beautiful.
Gonorrhea.
Life imitating art. No.
So the one that I'm thinking of is when George has this massive book. I think it's on business or something like that, or like business or management strategies. And he doesn't want to read it. And he finds that there's a resource that can make it into essentially what we know now as an audiobook. And he is disappointed when the narrator sounds just like him. He doesn't want to hear his own voice. George Costanza, always trying to get out of things.
I again, I think it's really something that, especially with AI and with all the work that, I mean, we'd use actually a ton of AI in foundations.
Yeah.
It's amazing how much that is probably going to take over the learning space.
Yeah.
Like audio, like
Yeah.
even podcasts. I mean, the podcast space has exploded over the last 5 to 10 years. And I mean, we've engaged with basically mostly audio
Yeah.
sort of environment or milieu for sort of getting the message across through a podcast. I do think that it's only going to grow, especially with like AI generated podcasts that people can use for learning purposes. So I don't think that books have seen their last page or their last chapter, but I do think that audiobooks are here to stay.
Yeah.
And especially with the onset of and the growth of the podcast industry too.
Yeah.
Yeah. Well, Central Liners, it's up to you to determine this week's winner of the test of friendship. Audiobooks, is this considered real reading or not? This also leads us nicely into week 3 of Foundations, where we have the opportunity to engage in the first story of the week, which you can read, listen to, or do both, starting on Monday.
We are so excited to finally share the first story of the week with you, and we look forward to our first discussion and analysis of the story at the end of next week. Think of it as the Foundations Book Club.
Yeah, make sure to read it. Don't forget, don't go for the Coles Notes or watch a movie like George Costanza did on Seinfeld, although a movie might be a fun idea.
Well, next year.
Yeah.
That's it for this episode, Central Liners. A big thank you for your engagement in the course so far and the amazing questions.
See you next week.